Hello, everyone. My name is Stephanie Broxton, and welcome to the Smarter Together webinar series. This webinar series touches upon how multidisciplinary applied research can be used to make a community impact and improve the human condition. Before we begin, I would like to remind all attendees to keep your audio and video muted throughout the duration of the presentation. At the conclusion of this presentation, there will be a short Q&A session with any remaining time. If you have questions for our presenters, please feel free to put them in the chat box at any time, and I'll read them to the presenters at the designated time. At this time, I'd like to welcome Greg McCormick, the director of the Georgia Smart Communities Challenge, to introduce today's presentation.
Thank you so much, Stephanie. Good afternoon, everyone. Again, I'm Greg McCormick, director of the Georgia Smart Communities Challenge. We're thrilled to have you with us today as we have a presentation from the City of Savannah's Georgia Smart program. They've been working on this program for the past year. Their project is Civic Data Science in Savannah. And again, they're one of 4 communities that participated in Georgia Smart over the past year. And they are the last to present. So after today's presentation, that will be the conclusion of Georgia Smart 2020. And we're so thankful for those 4 communities for participating this past year. Again, they were Sandy Springs, Clayton County, Valdosta, and Savannah. So all 4 communities worked incredibly hard to advance their projects and to make a real impact in their communities over the past year. And we hope that that impact continues on into the future. If you did miss their presentation, which happened over the past few weeks, you can watch or rewatch those recordings, which can be found on our website at pingeorgia.org. So at this time, I'd now like to introduce the City of Savannah Project Coordinator, Brian Brainerd, to kick off the presentation. Welcome, Brian.
Thank you, Greg. Good morning, everyone. I'm pleased to be here on behalf of the team as the team leader for Savannah's 2020 Georgia Smart Communities Challenge. I'm going to briefly go over the background on the project that we have been working on, Civic Data Science, to eliminate blight and improve equitable development. And then we'll have both the graduate research assistants who've worked with us on this project, Xiaofan Liang, who has been working on a blight model, and Vincent Gu, who has been working on how to evaluate the economic impacts to the real estate market of these interventions that we do. So the issue that we're really working on dealing with is vacant, abandoned, and disinvested properties and getting those back into productive use. We believe this is an equitable development strategy because vacant, abandoned housing actually has negative external effects on the surrounding property, lowering their property values, while the vacant property itself is an underutilized property that could be put to more productive use. And what we do with the City of Savannah Housing and Neighborhood Services Department is help people buy homes for housing security, and we also help new homes get built for people to buy using HUD-funded sources. Over the last number of years, we do field surveys with the housing department to evaluate housing conditions throughout the city. And over the last couple of years, we've identified over 1,400 vacant properties. And these properties cost the city money, not only in lost tax revenue, but also in other costs of police, fire, code compliance, and court costs. Also, these low value properties are difficult to get loans on to purchase. And so even though a property may be worth less than $50,000, it's impossible to get a loan from most lenders. So what we try to do is evaluate and mitigate the vacant properties, starting with code compliance, and then we have more robust tools that we're implementing, including nuisance abatement, title clearing, so that the house has a marketable title and can be sold properly, housing renovations or new construction of existing buildings. So, for example, one of our partners in the housing ecosystem here in Savannah is the Land Bank Authority, and they are specifically chartered to be able to acquire property and put it back into productive use through a variety of methods. When we do have to mitigate property through demolition, as we did in West Savannah, we start by a number of reviews of the property and take it through a process whereby we can demolish that property and make room for new property. And typically, neighborhood residents are a big part of that process, helping us to identify and support removal of these vacant buildings, as we did in West Savannah, where the neighborhood president was on hand for the demolition. Once the site is cleared, then we prepare and help finance construction of a new house to be sold to an affordable home buyer. A big part of helping people get into affordable housing, especially home ownership, is working with them to get their credit improved so that they can get the loan that's necessary from the private market. And then we use federal funds to fill the gap between what a income qualified homeowner can purchase it for and the actual cost of the property itself. And the goal is to make sure that even people who build houses like the gentleman finishing the concrete here on Cumming Street in West Savannah can also afford to live in the houses they build. Over the last 20 years, we've done hundreds of infills and down payment assistance for single family housing. You can see how they are distributed across the city of Savannah. And for this project, we're using a number of data sets that are important for mitigating and identifying blighted property. They come from the Savannah area GIS related to parcel digest and our civic administrative data that comes from our internal sources, including property code violations, crime, tax delinquency, and that sort of issue. And what we get are a big spreadsheet of data like this, which has its own interesting features to it, but how we turn that into actionable information is at the core of this project. And a quick review of who's involved is you'll see that at the center in the yellow boxes are the Georgia Smart team from Georgia Tech. We have co-PIs, Cleo Andrus and Omar Asensio. They are both faculty at Georgia Tech, and then they have research assistants working with them on these projects, Xiaofan Lang, Vincent Gu, Edward Chen, and then we had our Smart Communities intern, Bethany Laskin. At the right side of the screen, you'll see the people who work with the housing department on these housing interventions. That includes the Land Bank Authority, as we mentioned, CHSA Inc., which is a nonprofit housing developer and a financing institution. And we had Coastal Georgia Indicators Coalition doing some of our data research for us, surveying people in the city. This is an example of what the data looks like for a single parcel and how long it takes to get a parcel through the remediation process. It can be as short as 3 months doing a typical market rate transaction to over 18 months if you have to use nuisance abatement, tax sale, and quiet title or eminent domain. The other thing to keep in mind when we do these interventions is the block context. And as you can see in this example, this block on Cumming Street, where we've been very involved over the last couple of years, has had numerous vacant abandoned properties, and identifying all the related measures for each property is part of how we look at the entire block. And what we're trying to do is scale that up so that we can do this on a citywide scale, identify where the blocks that are best to intervene are located, and that way we can distribute our resources more equitably in neighborhoods where it matters. So the final decisions typically involve neighborhoods that are at the tipping point. Longer term efforts can be made, like we did on Cumming Street, to do more than a single property. The short answer about the academic literature is we know that most of what we do has a positive impact on the neighborhood and surrounding properties. What we don't know is exactly which interventions have which impacts. And so distinguishing how and what context a certain intervention may improve a neighborhood more effectively is some of the information we hope to learn from this whole project. So with that, I'll introduce you to Xiaofan Liang, who's been working on a model to identify blighted property and help us determine the best measure for intervention on that blighted property.
Hello, everyone. My name is Xiaofan Liang, and my project with Dr. Cleo Andres focuses on developing a human-in-the-loop machine learning model to identify vacant, abandoned, and disinvested properties. After conducting informal interviews with housing planners, we realized that the current process, which goes from acquiring data to surface candidate property to identifying the context for acquisition, is very time-consuming and can't scale with the city's vision. So we proposed a new process involving machine-human collaborations, in which our civic technology partner will pull and prepare data from multiple civic departments. The machine will generate VAD prediction based on the data, and our housing planner can visualize these predictive labels with other context layer to make holistic acquisition strategies. So we focused our work on the model development, and Bethany, our SCAD intern, worked with Brian to incorporate community inputs in the process. Next, please. So this is what our human-in-the-loop machine learning workflow looks like. The human-in-the-loop component is really exemplified by the iterations with housing experts and the deployment of active learning, which means that human actively teaching machine by providing labels. Given the limited time, we'll only show you the results from step 4 to 9 in the following slides. Next, please. Before I begin, I want to give non-technical audience a crash course on machine learning. Typically, we start with unlabeled data. In this case, these are property that we don't know whether they are VAD or not. Machine then is trained with label data, which is a black box process, and then generate prediction of a property being VAD or not based on what it has learned. At the end, we'll have a VAD label for each properties. Next, please. The tricky part of this in our project is that we don't really have a labeled data set of VAD properties. So existing data such as code violation may approximate VAD conditions, but we want to generate a label for VAD properties that are ready for acquisitions, which is not dependent on any one variable alone. So we decide to ask experts to label properties for us. However, there are 5K candidates out there, and our experts have limited time. So we want to maximize the efficiency of sampling, which means we provide expert with a diverse sample sets, and usually those difficult to judge on as well, so that the experts can maximize the learning experience for the machines. So here we used uncertainty sampling and diversity sampling to select 300 samples. I will show an example of what diversity sampling looks like. Next, please. On the left, the graphic represents different clusters of properties feature space. So you can understand that as different clusters as different types of VAD candidates. So some are high crime, while some other are tax delinquent alone. So we want to make sure that we have representative from each type. So on the right, the graphic shows the geographic distributions of the samples. So we want to make sure that the sample we pick are across racial and income lines, as well as touching all areas in the cities. Next, please. After we obtained the samples, we gave them to experts to label. This is an Excel interface that we provide to the expert for labeling, so that they are blind to where the property actually locates, but can only make decisions based on civic data and parcel attributes. Next, please. We also have 3 experts labeling the property at the same time, so they may disagree with each other on properties with similar conditions. So to ensure that the labels are consistent, we ran a decision tree on all the label samples and checked the side branches of the decision tree to make sure that the labels are consistent. So if there's like one or very few VAD property that takes multiple steps to be split in the decision tree, then they're suspicious to be inconsistent. Next, please. Then we train the machine learning model on the label data sets. The feature importance table right here tells us what the machine has learned and thus what they make predictions based on. So it's important for us to know that what the machine have learned and have some transparency in the predictions. So we experimented with a few model settings and feature combinations. There are a lot in this table, so I will walk you all through the table components step by step. The column name represents model settings, which we experimented with a full feature set and a reduced feature set. So the full feature set include all the variables on the right, on the left, and then the reduced features only contain crime, drugs, code, text, special assessment text, and property values. On the left in the column are all the variables used in the machine learning. So we also so these are the variables that goes into either full feature or reduced feature models. Next, please. We also experimented with 200 versus 300 sample size to see whether increasing the sample size has effect on accuracy. Next, please. And we also separated land and structures because they have different data availability, and the data threshold for each to be VAD is also different. Next, please. The number in the table represents feature importance. So the number means that if you drop this variable from the model, your model accuracy will drop by X percentage. Therefore, the higher the number, the more important is the feature. So next, please. And you can ignore numbers with the stars because they're inconclusive in terms of whether they're positively contributing to the model or not. Next, please. At the very end, we check model accuracy with two complementary matrices. So you can interpret these numbers as the percentage of samples predicted correctly if they are not in the training set. Next, please. So what insights do we get from the model? So we found that text, crime, and code violations are consistently important across experiment settings, which is consistent with the blight legal definitions. We also learned that our sample size is sufficient as our accuracy didn't fluctuate greatly with more samples. Reducing features turned out to help improve the model accuracy slightly, most likely because the rest of the variables introduce more noise than help in the model. We also need to be aware that, next, please. Next, please. So lastly, we also need to be aware that the importance of the crime and code may be overestimated, while the importance of text may be underestimated because we provided a highly biased training sample to the model. And in reality, in larger data sets, there are less property with code and crime violation, while there's more property with text delinquency. So all of these need to be considered when we pick the final model. Next, please. So with all these considerations, we use this setting as the model setting to run our prediction. Next, please. So to check the model robustness, we compare our machine-generated prediction with a human-generated targets list in 2019. So not surprisingly, the machine-generated predictions are more spatially diverse as they cover neighborhoods that humans do not have time to survey one by one. Among the human-found targets, 72% are also found by machine learning models, which is not bad considered that human-found targets may not be the absolute ground truth for VAD properties as well. So we also found, next please. We also found that machine learning predicted properties may have higher weights on crime, text delinquency, while human found properties tend to have more co-violations and low property values. In terms of co-violation, machine learning predicted land may have greater percentage than human found land property, but it's the opposite for structures. So, and this is a comparison generated by hypothesis provided by housing planners, as they're interested to see that whether as human driving around and checking out property, whether they focus on one factor more than others. Next, please. So lastly, we ran some preliminary analysis on 311 calls in Savannah to see whether there are neighborhoods where data are less reliable. So 311 calls are the source of co-violation data in Savannah. So low participation in 311 calls can lead to inaccurate representation of the code cases in the communities. So we identify some of these neighborhoods where code cases data may be less reliable for further checking. For example, West Savannah and Carver Heights have only 20% of the code cases coming from 311 calls, while for Ashmere and Sackville, more than 80% of the code cases actually come from 311 calls. Next, please. In conclusion, we produced a machine learning model that reaches 87 to 95% accuracy at predicting VAD lands or structures. We also produced a human-in-the-loop workflow that exemplify across disciplinary and public academia collaborations. We learned that human-in-the-loop is important in model development because it leads to trust and for all parties involved to use our model as the end outcome. We also learned that text, crime, and code are important in identifying VAD properties, and machine can generate more spatially diverse predictions that focus more on text and crime compared with human-found targets. We also are aware that some neighborhoods are more susceptible to data bias due to low participation in 311 calls. Thank you very much. That's the end of my presentation.
Thank you, Xiaofan. Next up is Vincent Gu, graduate research assistant in the Data Science and Policy Lab. Go ahead, Vincent.
Thank you very much, Brian, for the introduction. Hi, my name is Vincent, and I'm currently a graduate research assistant in Dr. Asensio's Data Science and Policy Lab. And now we will be presenting some of our findings with our collaboration with the city of Savannah. The main question that we seek to answer with our project is, what are the effects of low-income housing grants on property prices in Savannah? And the grants whose impact we try to measure are three main ones: down payment assistance, infill grants, and repair grants. However, in order to analyze the impacts of these grants, there were some challenges that we needed to overcome. First of all, we had to compile data from many different sources, including the city, county, as well as other private data sources. And this is a problem of record linkage because oftentimes these data sources might not be formatted consistently in that their addresses might be of different formats, maybe in different columns. And also there may be variations in the scales and units of the measures. And therefore we needed to undergo a process to compile and link all the data together into one single data set. After that, we needed to address the problem of self-selection bias, which is a common problem that is encountered in economic analyses. Put shortly, in the context of our project, houses in Savannah that participate in these three programs are often not reflective of the average Savannah house. And therefore, this relates to our third challenge, which is selecting an appropriate counterfactual group to compare to the treated property so that we're able to obtain accurate and fair measures of the impacts of these three grants. Next slide, please. So one of the first tasks that we needed to do as part of this project is to collect data from a number of different sources. The city of Savannah and Brian provided us with a very large and comprehensive data set on the properties within Savannah with a lot of information about their characteristics. However, we found out that in order to accurately measure the impacts of these grants, we needed data from other data sources. One of the most important data sources that we obtained from was the Chatham County Tax Assessor website, which contained time variant property and tax information for properties within the county between 2011 and 2020. And this is important for us because we needed to see how property values evolved across time, as well as how the the 3 different interventions may have impacted that evolution. And so to individually look up all of the properties on that website is extremely cumbersome. And therefore, our other research assistant in the group, Edward Chen, developed a Python code using the web scraping tools Beautiful Soup and Selenium in order to automate this process. And we're able to successfully implement this code and scrape tax and property information for more than 100,000 properties over the course of about a week. And not only were we able to do this, but we presented this code to the city of Savannah during our field visit. We were able to demonstrate to Brian how to use this code, and he is subsequently able to train other city officials to use this code in order to obtain county level data. And this is important since it overcomes common issues of data siloing within public administration and allows city officials to access data that they otherwise would not have within their database. Next slide, please. After obtaining scraping data, we needed to compile them together into master data sets. And as you can see, we matched different properties together based on parcel ID, which is the most consistent formatting between each of these different data sets, between the county, the city, as well as housing policy records. Not only did we compile data from city and county sources, but we also obtained data from non-city sources, which provided to us important information for analysis purposes. One of the biggest data sets that we were able to obtain data from was Atom real estate data from a private data aggregator called Atom Data Solutions. And that data set provided to us the geospatial coordinates, latitude and longitude information for each of the properties, allowing us to plot each of the properties on GIS and be able to conduct some spatial analyses. We also compiled data from a number of neighborhood level data sets, such as FEMA flood zones, school districts, parks and recreations data, walk and bike scores, as well as census data that contained important demographic variables such as racial composition, as well as household income characteristics. Next slide, please. And this map provides an overview of the data, all the data for the properties that we have on file. It is, as you can see, we have a lot of data for properties distributed throughout Chatham County. However, a preliminary spatial a descriptive assessment of this map shows that the properties that receive the treatment tend to be concentrated in specific neighborhoods. And this provides us some preliminary evidence that the average property in Savannah cannot necessarily be directly compared to the treated properties. And this provides us with one of the challenges that we will need to overcome. Next slide, please. So after combining all of the data sets into a single master data set, we need to select an appropriate counterfactual group in order to have a much more accurate comparison. So the next step would be to select key matching features. Because we compiled from many different data sets, we have a large set of variables numbering up to close to 100. However, many of these variables are closely correlated to each other. For example, living size, as well as other variables that measure size that may be very similar. And this would cause problems for us later on in our model. And therefore, our first step after combining all the data sets is to identify suitable variables for matching and analysis. And we do this by looking at a correlation matrix between all of the variables to see which ones are related to each other and select the ones that are most relevant. We also look at prior literature to see what prior research on housing models on housing and property values have concluded as to which variables have the most impact on prices, so that we select the most relevant ones. We then conduct a propensity score matching, which is a matching algorithm that allows us to match policy treated and control groups for similar characteristics, so that we have a control group that seeks to limit and minimize the self-selection bias. And after doing that, we conduct a regression with this matched group in order to quantify the effects of each of the 3 policy treatments on property values, so that we're able to acquire estimates of market returns of each of these interventions. Next slide, please. So we will now present an overview of some of the results for each of these different steps. This chart provides us with the outcome of the propensity score matching. Within this chart, you see many of the variables that we have for property characteristics on the left-hand side columns. The variables highlighted in yellow were the variables that were selected for matching. And as you can see, not only was the algorithm able to reduce bias in the matched variables, but because a lot of the other variables were closely correlated with them, we were also able to reduce bias for many of the other variables to have a much better data set in terms of much less biased sample. Next slide, please. We also were able to do this for neighborhood characteristics, in which we used the neighborhood of the treated property as a parameter for matching. And as you can see from this chart, before matching, many of the treated properties tended to be located in neighborhoods that had higher percentage of minority and African-American populations, had higher population density, as well as neighborhoods that have lower median household income, as well as lower income per capita. But through matching, we were able to select properties that were more closely corresponding to the treated properties, and we were able to reduce the bias in these variables to near zero. Next slide, please. So after matching, we were able to conduct a staggered differences and differences regression, in which we not only quantify the impact of each of the interventions, but also in that model, we take into account the difficulty that not all properties were treated at the exact same time, exact same year, and therefore we needed to account for different years of treatment. And based on our results, we were able to find that the down payment assistance and infill grants generated some positive market returns for the properties. Infill grants especially were able to generate a much more substantial positive market return of about $20 per square foot. However, due to a limited sample size, since there weren't as many counts of infill properties as the other grants, we need to interpret the results with more caution and also need to undertake more steps to check the robustness of these results. Next slide, please. In contrast, for repair grants, we didn't find the results were less favorable in terms of the market outcomes. We find that the receipt of a repair grant tends to be correlated with a slight decrease in the square footage. However, this doesn't mean that the repair grants were not beneficial for the occupants of the house. It just means that they were not rewarded by the market. And even though we still need to find out the cause of this, upon conversing with city officials during the visit, we suspect that one of the key causes might be issues of deferred maintenance, in which repair grants revealed aspects of the house that might have been expected to have been fixed before. And that is something that we need to study further as part of our subsequent analysis. Next slide, please. So to sum up what we've achieved so far, we've been able to integrate civic data from both private and public sources. We found some evidence of positive market returns for the DPA and infill grants, but for the repair grants, we found the need to go beyond market data and in order to assess less visible impacts that might not be captured by the market, such as quality of life improvements that we will only be able to study qualitatively through interviews, for example. We also were able to train city officials on automated downloading of county assessor data through web scraping tools, and which overcomes issues of data silos that are often present in public administration. We also established an ongoing research collaboration on housing analytics that will go beyond this project through our National Science Foundation sponsored grant. Next slide, please. Of course, the previous results only constitute the initial part of our analysis. The more important part of the analysis is to study the spillover effects of these interventions and look at their neighborhood level impacts. This is especially true for infill properties because for infill, the city spends money to construct a property in a neighborhood in order to spur market development. And therefore, the very nature of infill grants is to try to induce neighborhood level improvements. And therefore, this would be our next step in our analysis to try to look at community level impacts. We want to learn about the context of each of the different neighborhoods and each of the different infill properties to identify appropriate models to study impacts. We're also undergoing a process with Brian and the city to audit the data to make sure that all of the infills accurately correspond to what Brian has as his list of infill properties, so that we're able to make sure that we capture all of the impacts of the infills correctly. We then would conduct a spatial analysis to study the neighborhood impacts and empirically measure the extent of market impacts on properties around each infill to see to what extent were they able to bring in neighborhood level impacts to the city of Savannah. Thank you very much. And this concludes this part of the presentation. And I will now turn the presentation back to Brian.
Thank you, Vincent. That was a great presentation from you and Jalfan. It's been great working with both of you. You might have noticed that the data we're working with is typically in the civic data about negative factors related to properties and neighborhoods, code enforcement, crime, unpaid taxes, that sort of thing. And so what's missing from the data was one of the questions that came up as we started this project during the fall data workshop that the Georgia SMART program held for us. And there are a number of reasons we wanted to look at other types of data. One is to fill data gaps. The other is to collect qualitative data. So while we have a lot of negative factors measured through the civic administrative data, we don't have good measures of the positive aspects of a neighborhood. And so that was really important to us. How do we balance these factors, and how do we keep from creating or stigmatizing neighborhoods based on discussions of these factors? And some neighborhoods may have more of these factors than others, and that tends to create a certain type of bias related to our conversation about those neighborhoods. And then we also wondered if there were ways that we could engage communities more effectively and help them be a part of the solution. This was a great opportunity to involve the GIFT program interns, as well as our own research assistants. And this is an example where we were out in Savannah Gardens, a neighborhood that has been redeveloped over the last 20 years through the vision of the housing director and city leaders, which has resulted in over 700 units of new affordable housing. So even though we never intended to do a single survey or collect extra data, when we began this grant, the workshop that we held in the fall convinced us there were opportunities and a need to do so. So we worked with Georgia Coastal Indicators Coalition to do a more traditional type of survey instrument related to perceptions of neighborhood residents. And then we looked at citizen applications that are mobile applications that would allow citizens to give us data, provide data. And we looked at two types. One was using a 311 type of system, and another was using just a standalone application that allowed people to do neighborhood surveys, and is being used in a number of cities nationwide to address blighted conditions. Turns out that the 311 approach was difficult to do in the context of this program because of the amount of time it would take to launch a pilot. It involved two separate divisions of the city, both city manager's department and community services department. And so when we talk about siloed data, there's a reason data is siloed, because the administrative departments have a chain of command, and that chain of command goes up, not across silos. And so this is one reason we find that we have a lot of data in silos. We use a ESRI survey instrument as well in the city, Survey 123, and field maps. That's typically used with our windshield survey of housing conditions, and doesn't really address the human perceptions of housing. And the thing we really like about the self-service application, which is called Regrid, is that it's very low cost. An individual can start doing surveys on their own, and you can get a subscription to this program for $10 a month. It's specifically oriented towards grassroots applications so that a neighborhood can undertake one of these surveys and produce it on their own. These are our canvassers who were out surveying the Cloverdale neighborhood. We branded this survey that the Coastal Georgia Indicators Coalition did as the Neighborhood Insight Survey. They canvassed entire blocks throughout the neighborhoods where we do most of our work. And as you can see on this map, I've highlighted that the areas that were in yellow that were selected as the randomly selected blocks in the neighborhoods where we do most of our work. The level of purple indicates the percentage of African-American households on those blocks in the 2010 election, in the 2010 census. So we will have new data this year to see how much change has occurred in that household composition. The information we got from the neighborhoods perception survey was then aggregated by the Coastal Georgia Indicators Coalition to keep a third-party barrier and allow people to feel more free to answer questions from this third-party nonprofit rather than having city staff asking these questions. And they're going to be stewards for the data. And then we've just gotten this in the last couple of weeks, so we haven't had time to dig into it very deeply, but just a quick overview highlights that many neighborhoods are concerned about the safety in their neighborhoods, as you can see on that row highlighted in yellow. And then what people like about their neighborhoods tend to be their neighbors and the places they live, as you see in the bottom half, the top two rows of the bottom half with the green shading indicate those levels. So we'll have more analytics done on this as we progress throughout the next year. This is our team doing the field survey. Both the gift interns, our smart communities interns, research assistants, and Dr. Andrus there on the right, who's working with Xiaofan. The self-service application Regrid looks like this when people do the surveys, and you can see across the bottom. We did a simple rating system for each block that we surveyed, and this was just a pilot to see how we would go about cataloging the positive qualities about each and every block. The lessons we've learned in this process is there's the need for the right data. You can have lots of data and still not have the right pieces of data you need. And even as I saw with the researchers working with data, even among all the data sets, there's a lot of work put into identifying which data was the right piece of data and not eliminating and the need to eliminate similar data and have only one data representing a particular aspect that you're interested in. There are barriers to data collection. One of the most significant that I ran into during this whole project was just cultural change, organizational culture, getting people to adopt new technologies. We still have some people that prefer to do things on hard copy paper rather than working on a tablet or a modern device. And then that we also identified opportunities for engaging with hard to reach citizens through some of these applications. So thank you very much. This is a list of our team and contact information, and we appreciate your attention during this seminar.
Thank you so much for that very detailed presentation about all the great work you guys have accomplished in the city of Savannah over the last year. We have ample time left for audience questions, so we really encourage our attendees to put any questions you have for our panelists into the chat box at this time. I'll get us started with an initial question, which is, what advice would you have for other communities in Georgia who want to take on similar smart housing data projects in their communities?
I guess I'll start with that one. I think doing the research beforehand, this process really has been a 3-year process for me and a lot of the staff at the city. This really is just another step in the data journey that we actually have been on for the last 4 or 5 years. And that included, creating a data hub, which is similar to Dr. Asensio's project in Albany, Georgia, where 2 years ago, the city of Albany introduced a project to improve their data. And we undertook a similar project and still found that we needed to have a better understanding of how to analyze the data, and that some of these new emerging tools and strategies, such as, within the data science and data analytics world, look like they could be very helpful because these projects are very complicated. The factors related to housing blight are difficult to assess independently, and so it seemed like this was a good fit for us. And I think that the whole process has actually made us think more carefully about how we are analyzing the data, and it's kind of a continuous feedback loop, working with the researchers who are developing models to help us think more clearly and critically about the data we're using, and learning in this process at the same time.
Absolutely. So you mentioned briefly that cultural and structural change was one of the challenges you experienced in trying to execute this project. What key stakeholders would you say are essential to have on board for projects like this one?
I think, it's really been our whole leadership in the neighborhood services and community services division, starting with our chief, Taffney Young, and my boss, the housing director, Martin Freddy. We got started about 7 years ago looking at specific data points and how these might help guide us with our interventions in neighborhoods where we can most effectively invest the limited amount of federal funds we have to help people have better housing. And that all started with all those basic data sets of code compliance, crime, unpaid taxes, and that was all a manual process. And so it's been a continuous cycle of moving from spreadsheets to databases. And so without the leadership within the city, that would not happen.
Thanks so much. And to kind of a similar question for our researchers, I know some of the challenges that you guys experienced were kind of outlined in your slides, but if you have any additional feedback on how to overcome some of those challenges you experienced, that might be great advice for some other people who are trying to take on projects like this. We'd like to hear from you guys as well.
Okay. Okay, I guess I can say a few words on that.
Thank you.
I'll start and then maybe Cleo can say a few words, or students. I just want to say that, the biggest part here is just the value and the role of collaboration. I think it's a wonderful partnership between Georgia Tech and, city leaders. In this case, Brian has done a tremendous job interfacing with us and, understanding the needs of the researcher and needs of the, modeling exercises are often, a lot more involved than what we would typically do with, analysis within the city. And so I think having that mutual understanding and relationship is very important. So relationship building is number one in terms of building trust together with the community. And I would say that's probably our biggest, hurdle is how to translate and speak different languages. Of course, when we're talking about modeling, there may be one set of languages we use. And then when we talk about, how to translate that for practice, we also, as researchers, need to have those insights as to what's important. So, in our case, we've looked at a number of different ways of analyzing data, and we're just very excited that we have a great partner who, like City of Savannah, who is dedicated to engaging with academic research. And it's been a wonderful experience. I'll just leave it there, and I'll turn it over to Cleo.
Thank you. She might be having a little technical difficulties, but if you guys do find that you have any other questions, please feel free to reach out to myself or any of the folks listed here on the Savannah project team. I think they would be happy to answer your questions if you find that you have any after the presentation. At this time, I'd like to welcome Greg McCormick back to say a few closing words for us.
Thanks so much, Stephanie. Cleo, it looked like maybe your microphone just wasn't working. Apologize for that. So everyone, just wanted to say thank you so much for the hard work and dedication that all of you on the Savannah team and at Georgia Tech, the research partners and their partners on the program put in for this project. It's clear that this really will make a very positive impact in improving housing in Savannah, and really continues to improve and establish a template for other communities in Georgia to look at in incorporating data and looking at data-centric models for improving housing stock in our communities. So really important problem that's being addressed by this project. So additionally, I wanted to say thank you to all the members of the Partnership for Inclusive Innovation who make Georgia Smart possible, specifically Deborah Lamb, Stephanie Broxton, Christy Kirkland, Jamal Lewis, and Morgan Davis. So thank you to you all for continuing to develop this partnership and make it available to all the communities throughout the state of Georgia. It's an incredible asset to our state. So lastly, obviously, I wanted to thank everyone for attending today. We hope you have learned something from this project as well as the other 3 projects in Georgia Smart this year, and take those lessons learned and take them back to your communities to hopefully make your communities more inclusive and more sustainable in the future. So all 4 final presentations will be available soon for download for your review from the website. So you'll have access to the slides that all the presenters talked to today and in previous presentations. This now closes out the Georgia Smart Communities Challenge for 2020. Thank you to everyone and have a great day.